Hello, and welcome to the AI Research Roundup. I'm your host, Alex, and today is May 8th, 2025. We're looking at an ICLR conference paper titled MMQA, Evaluating LLMs with Multi-Table, Multi-Hop Complex Questions, published just over 3 months ago. This paper introduces a new dataset, MMQA, that's Multi-Table, Multi-Hop Question Answering. It's designed to test how large language models, or LLMs, handle complex questions needing info from several data tables. This often means multi-hop reasoning, connecting data across tables linked by primary keys, which are unique row IDs, and foreign keys, which create those links between tables. Alright, so this first figure really sets the stage. It shows an example from the multi-table, multi-hop question answering benchmark. We see 3 different tables: head, management, and department, and a question asking for creation years. To answer this, the system has to perform multi-table reasoning. It starts by finding specific information in the head table, then uses a head ID, which is a primary key, to find related data in the management table. From there, it uses a department ID, acting as a foreign key, to jump to the department table for the final answer. This visualizes the exact kind of multi-hop challenge these researchers are evaluating. Building on that, Figure 2 illustrates the evaluation framework. First, in Step 1, multi-table retrieval, the large language model selects relevant tables from a larger collection, a table corpus, based on the question. Then, Step 2, multi-table evaluation, tests the model's reasoning across these tables. This includes tasks like text-to-SQL generation, that's converting questions into structured query language, a database language, plus primary key and foreign key selection, and multi-table question answering. This framework systematically assesses the large language model's capabilities. Alright, so this next table, Table 1, delves into the specifics of the multi-table, multi-hop question answering dataset. It breaks down statistics for both 2-table and 3-table question scenarios. For example, in 2-table setups, there are nearly 2,600 tables involved, averaging over 1,800 rows each. A key metric here is inter-human agreement, which measures how consistently different people answer the same questions. It's 86% for 2-table tasks, showing the questions are quite clear. The table also details question types, such as numerical or select questions. Okay, so building on those dataset statistics, Table 3 gives us concrete examples of these multi-table, multi-hop question answering questions. It lays out different question types, like numerical, list, count, and select, for both 2-table and 3-table scenarios. And importantly, it emphasizes keywords within the actual questions that point to the relevant columns in the different tables. This really helps visualize the complexity the large language models are up against when trying to connect information across these multiple tables to find an answer. So, to really put the multi-table, multi-hop question answering benchmark into perspective, this next table, Table 2, compares it directly with previous table question answering benchmarks. The most striking difference, as you can see, is that almost all prior benchmarks focus on single-table tasks. In contrast, the multi-table, multi-hop question answering benchmark is specifically designed for multi-table scenarios involving natural language questions, or NL questions as they're abbreviated here, and a wider array of tasks like primary key and foreign key selection, setting it apart. And to further illustrate what sets it apart, this next figure, Figure 3, really drives home the complexity. It's a bar chart showing the average reasoning steps, which you can think of as the number of logical connections or information lookups needed to arrive at an answer across several different datasets. The multi-table, multi-hop question answering benchmark clearly requires the most, with an average of 7.61 reasoning steps. This is substantially more than others, visually confirming its more demanding multi-hop nature. So after seeing how the multi-table, multi-hop question answering benchmark demands significantly more reasoning steps, the main takeaway is clear. While large language models are advancing, their performance on these complex multi-table tasks, like accurately finding and connecting information, still falls far short of human capabilities. However, new strategies for helping models retrieve the right tables are showing promise. Ultimately, this benchmark highlights current limitations and guides future work towards more capable AI. Thanks for tuning into the AI Research Roundup. I'm Alex, and I'll catch you next time.